Hello everyone, my name is Oren and I'm the head of the Scientific Computing Lab at the Nuclear Research Center Negev and the last year computer science doctoral student at Ben-Gurion University of the Negev. Our poster highlights ComPar, an optimized multi-compiler for automatic OpenMP source-to-source parallelization. So in the last decade, there is a growing trend of an increase in the number of cores of a given hardware. This is due to the end of the NARD scaling. Therefore, in order to maintain an increase in performance, vendors introduced the multicore and many-core architectures. These architectures use a new memory model, namely the shared memory model, in which multiple cores share the same physical memory space. To utilize those new architectures, new parallelism schemes and paradigms were created. The most prevalent shared memory parallelism scheme is OpenMP API. However, introducing OpenMP, especially to scientific legacy codes, is not a simple task, as it requires the user to thoroughly understand the code's semantic structure, its data dependencies, and the implications of their parallelization. In addition, the users are not necessarily experts in parallel programming, or lack the basic knowledge on how to parallelize using OpenMP. This leads to the creation of multiple S2S automatic parallelization compilers that attempt to automatically insert OpenMP directives to these codes. In a recent paper, we compared different S2S automatic parallelization compilers and focused on AutoPar, Cetus, and Par for all. Each of these compilers has its own data dependence algorithm and therefore producing different OpenMP directives. In the left graph, we can see the speedup they produced in comparison to the serial execution on NAS benchmarks. Clearly, there is no best compiler, but each compiler suits some problems better. Therefore, we created a new meta-compiler named ComPar that utilizes the advantages of the different compilers using code segmentation, fusion, and hyperparameters tuning in order to produce the best results out of all compilers. So how does ComPar actually work? ComPar enumerates all loops in the given source code and measures the running time for each one. Then, for every possible combination of a S2S compiler's flag, OpenMP clauses, and RTL routines, ComPar uses the S2S compiler to parallelize the code with the compiler flag specified in that combination. It then adds the directive clauses and OpenMP RTL routines to each parallelized loop. For every such combination and resulting parallel code, ComPar compiles and executes the parallel code and extracts the running time for each one. Finally, for every loop, ComPar chooses the parallelization scheme that produced the shortest running time across all combinations and creates a unified parallel code version in which each loop is parallelized using its empiric optimal parallelization scheme. To test ComPar and show that it does indeed produce the best results out of all three automatic parallelization compilers, we executed ComPar, AutoPar, Par for all, and Cetus on the NAS and Polybench benchmarks. As one can see from the graphs, ComPars always produced better results than each of the compilers, or at least as good as the best one. We can observe in the left graph that while some S2S compilers produced inferior runtimes than the serial execution, ComPar consistently reduced the code's running time. We can also see that while the speedups of the S2S parallelization compilers on the NAS benchmark were slim, the speedups on the Polybench benchmarks were substantial. This is due to the code parallelization compatibility. That's it. I was Oren. Thank you for listening. Bye-bye.